Okay, we're ready to start the third video. Well, actually it's the fourth because we had one that had to do with the simulator. Now, just remember to always go to the Ready for Robotics website and you can see a post which will tell you a little bit about this. And the other thing I think you want to be doing is to carry around that drawing that you had, or draw a new one. I mean, I draw it all the time. Sit here and say, okay, here we go. I draw it like so and put the input and the output boxes here. I stick the A guy here and I stick a little robot there, stick the PC here. Remember, this has 3 digits, and then I put all the mailboxes over here to 99, and then you've got that little +1 button because every time the robot does the fetch cycle, it kicks us up for to move the program counter up to 1, because all the programs, most of the programs, are sequential. And then we'll show how other things work. And you've got the input, you've got the output here, and then we had the start and the stop buttons, etc. So you've got those things in there. So once you just keep that in your mind, and then when you look at the simulator, the simulator's a little different. And let me just draw it. It has its output thing up at the top, and then it's got a sort of a big thing here in the middle which has the PC here, and then it's got an instruction register and where the instructions go, and then it's got the A register in here, down here, and then it's got a little box here which does arithmetic. I always call it the arithmetic and logic unit, and then it's got an input down here of the 3 numbers. So this is the simulator, and you know, it's got pipes here, and then it's got this big box over here with 0, 0, and 99 here. So they're equivalent. I mean, the A register is the same, so it shouldn't be too hard. The only other thing I think that Peter did with his simulator is that when the robot starts to run the program counter, he goes and increases it by 1 simultaneously while they go and go and find the instruction. And that's fine. That's probably very close to the way it's done in the real world. And again, the big difference will be in the real world, there'll be tons of these registers in there. I mean, typically even in a small computer, you'll have 32 of them. And there are a lot of stuff in between registers, and then you'll have your memory boxes out here, and there'll be a lot of action back and forth. So there are all sorts of commands to make the thing more efficient. But you have to understand that while this is really slow for us, in the simulator, they can do many millions of these things per second. So they are very, very quick. Okay, now, last time, what we were really trying to do, get my notes here, was I talked about loops. And so let me just throw a program out here for you. Okay, so we're going to go 901, which means input, of course. And I'm going to do 390. And then I'm going to do 901 again, so I can input the second number. Remember, we've stored it in 90. And then I'm going to do 190. I'm going to add it back. Now I'm going to give you another command, which is 601. Now remember, this is in location 0. This one's in 1. This one's in 2. 3 and 4. So what this says is, no matter what, when you get here, don't go to number 5. You'll never get to number 5. Go back to number 1. Now, I'll explain this right away, but you might want to stop and think about this a little bit. Okay, so what happens? You input a number, you store it. You input another number, and it's sitting in the A register. And then you add it, whatever was in 90, which you'd stored the first number. So you got the sum here. Now, you go back, and you've got the sum in the A register. You go back, now it sticks it in 90. Inputs another number, adds it to whatever was in 90. It goes back again, stores the A register and whatever's in the A register in 90. So as you can see, this thing will go click, 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 and storage location number 90, which is sitting right here, in the box, that will in fact keep increasing over and over and over and over. Now that's fine, And that allows you to input an infinite number of numbers if you want, any kind, whatever. But you can't get them out. So the big problem is how to get that out. And when I say number, I mean the summation sign. So what I do, you ought to stop now. What I do is go into that simulator and just stick these numbers in here and kick run and just input numbers and then watch cell number 90 in the mailboxes, and you'll see what'll happen. So this is your classic loop. In fact, this would be called an infinite loop because it goes on forever. Now, if you didn't have input in here and you were doing something else in the computer, it would just run and run and run and run and never stop. And often you want to avoid that. Sometimes it's absolutely necessary to have the computer go through a sequence of things over and over and over and over again. All right. Now I'm going to introduce another. Here's the problem. I want to input numbers and calculate the sum until I input a 0, and then I want to output. Okay. The way I can do that is I can go back up to this program and I'm going to change it. What I want to do here on one is just before 190, what I want to do is put a different test in. I'm going to say 720. Now, what is 720? 7 says jump to location 20 or stick 20 in the program counter, but the way I tend to think of it is you'll be jumping to location 20 and there'll be an instruction there, and then in location 20 we're going to put in 590, and I don't know if you remember 590, but 590 says take whatever's in 90 and bring it back into the A register. So this says, well, I'm running out of space here, but anyway, this says take 90 and stick it into the A register. So I've just input something, and I'm looking, but it will only jump if the A register is 0. So the A register is 0 because I inputted a 0. Then it jumps up to 20, and then in 21 will be 902, which is the output. Now, what I would suggest you do is input this thing, but now notice something had happened. If this were a more complicated program, this would really be annoying, but now you notice if you put 720 in there, it will go into location 3, and then this will have to go to 4, this one will have to go to 5, and of course this is 6 sitting here at 0, 0, 0. But 22, of course, will be 0, 0, 0. So if you put this program in and put it in the simulator and run it, then what will happen is it will do just what it was doing here before. It'll just be going jumpity jump back and forth until you see a 0 in. And if a 0 comes in, it will jump here. It will load the 90 back into the A register and output it. Okay, one of the problems is with this type of approach, it sounds real cute and everything, but if you happen to have a whole bunch of data, say on a file, and you're going to read it in automatically, then you might have a 0 in there, and if you had a 0 in there, it would just stop and add and give you the sum only up to that 0, and then dump out the output, and you wouldn't know any difference. So again, take a look at that simulator. We've got this, and you've now learned all the commands except number 8. And 8 really says, I mean, I'll just tell you right now, I think I did before, 8xx, it's the same thing as put xx in the PC, which means basically the next statement will jump there, but only if the contents of the A register is greater than 0. So I'll stop right now, and then I'll bring up that simulator and go through a couple of these things so you can see them too. But please, look, it doesn't do you that much good just to watch me do something. Do it yourself. Go through this thing. Keep this diagram in your mind and make sure you understand exactly what every step is doing. And if you do that, then this stuff will start to make sense. Okay. You can look in that simulator and see some really complex programs, but this will be the last time we'll just program with numbers only. Then it's very hard to program with numbers only. If there's any kind of complexity, you go crazy. And if you make a mistake, then you got to shove all the different ones down, just like we did here, going to 3, 4, 5, and 6. So we'll use mnemonics, and that will work out much, much better. Okay, that's it for number 3.